Hello everyone, this is Aesha Hiteshbhai Patel and this is the assignment of MHF4U Unit 3 Mid-Unit Assignment. Here we got three questions and I have solved them with proper solution. So I am going to show my solution and all three questions are completely solved. So let's start from first. So my first question is, describe what happened to the domain and range of logarithm function under a vertical reflection. Support your explanation with diagrams. So here first we have to assume function f of x will be equals to log of x is the function and its reflection at about vertical axis, that is y axis, is given by g of x will be equals to log minus x. So range and domain of function f of x will be equals to log x. So domain will be equals to this. Then we'll go same for range. So here in the interval 0 will be greater than x and x will be greater than 1. We have log of x that will be greater than 0, and in the interval 1 will be greater than equal to x and that will be greater than equal to this. So we have log x that is smaller than equal to 0. So now for range we are getting this equation. Now here we are getting range and domain of function g of x will be equals to log x minus x. So minus x is greater than 0 and that will be equals to x greater than 0. So domain will be this one. Then here we are getting for range, and here it is graph below shows the reflection of function f of x that will be equals to log x about y axis. The function f of x is increasing function whereas its reflection is decreasing. Domain of reflection is different but range is same. So here the graph is there. Now let's move to second number question. So second number question is, describe what happened to the domain and range of logarithm function under both a horizontal and a vertical transaction. Support your explanation with diagram. So here assume function f of x is equals to log of x is the function and its horizontal transaction is given by g of x that will be equals to log x plus c. So here as the function f of x will be equals to log x as domain x and range has this one. Then range and domain of function g of x will be equals to log x plus c. So here x plus c will be greater than 0. Log function is defined for argument greater than 0 and here for domain is this one. Then in the interval minus c will be greater than x and x will be greater than 0. We have log of x plus 6 and that will be x plus c and that will be greater than 0, and in the interval this we have log and that will be greater than equal to 0, and here it is for range this one, and now it would be graph. So graph below shows the horizontal transaction of function f of x will be equals to log of x. So here let's see the graph once. Yes, and here it is the graph. The domain is different but range remains same. The domain is different but the range is same in this graph. And here some I have wrote. Assume function f of x will be equals to log of x is the function and its vertical transaction is given by g of x will be equals to log x plus c. And then function and range and domain here are there. Here it is for range and this is for domain. Then the continue solution is there for second number only, and in the interval this will we have log of x plus c and that will be greater than 0, and in the interval this we have log in x plus c and that will be smaller than greater than 0, and it is this one, this function is for range. And here again one graph. So graph below shows the vertical transaction of function of f of x will be equals to log of x. The function f of x and its transaction g of x increasing, and here it is the graph. Here we can see very lightly that I have drawn the straight line upon this. the straight line. So this is the graph, and here are horizontal transaction, domain different but range same. Vertical transaction, domain and range are both are same in this one. Then our third question, last. So graph the function f of x that will be equals to 1 by 2 log x minus 4. Horizontal and vertical sketches are comparison. So given the graph of a function f of x, then the graph of the function af bx minus h plus k is, here are, I have wrote all that vertical scratched by a factor of a if a is greater than 1. Then it is same for all. I have wrote for compressed, then again here horizontally compressed and here horizontally stretched. Then here shift for h units to left, right and left, and here up and down. You can see here. Then our A number question is A. The line y is equals to x on the same grid. So in this case the function f of x will be equals to 1 by 2 log x minus 4. So A will be equals to 1 by 2, B will be equals to 1, H will be equals to 0 and K will be equals to minus 4. Then here the transformation to apply to the parent graph of y will be equals to log x is a vertical comparison by a factor of 1 by 2 and vertically transaction 4 units down. So using the two characteristic point 1 and 0 and 10 and 1 on the graph, log x and apply this transformation. So we are applying this two, using these 2 points on the graph, we are applying this transformation. So here it is, we can see the straight line, here it is, and here one line there. So this is the graph of A. Now B, here it is graph the inverse function f raised to minus 1x by reflecting f of x in the line y is equals to x. So here are there is the graph of two functions that are increased and are systematic with respect to the line y is equals to x. So for the graph of the inverse f of minus 1 of this function, simple reflect the graph of f from the graph above through the line y will be equals to x. Here it is the same graph which is in A, but here it is reflection. In A this line was here, this was the same, but here in A this was here, and in B we have to reflect the graph, so this line will go here. So you can see here. And now our C question is determine the domain range and equation of the aspect of f raised to 1 as f raised to minus 1 of x. So for the domain of the inverse function as f raised to minus 1. So since f raised to minus 1 is the inverse of logarithm function, this is an exponential function. Now here you can see I have done the solution. Recall the exponential functions are defined for all values of x in the set of real number. Then the domain of f of raised to minus 1 is this. Then for range, here it is for range. Therefore range is this. As it is said above, therefore the range you can see here. Then here it is D number last. Determine an equation for f raised to minus 1x. So find the function inverse functions f raised to minus 1 as shown below. Follow this step. So by following this step we will get the inverse function. So here from here we will start, that is f raised to x will be equals to 1 by 2 log x minus 4. Y will be equals to 1 by 2 log x minus 4. This is for set y equals to fx. Then interchange x and y, solve for y, this one. Here we have to solve for y. Then here we'll get 1 by 2 log y will be equals to x plus 4. How we are getting this? Because x will move this side. Here it is wrote solve for y. So this x will move this side. So x and 4 will get. So x plus 4. Then log y will be equals to 2x plus 8. Rewrite in exponential form. Now x will be equals to 10, 2x raised to 2x plus 8. Now this will go in raised to. Y will be go first. So y will be equals to 10. This 10 and this 2 digit will go into raised to, like 10 raised to 2 x plus 8. Set y will be equals to f of f raised to minus 1 x. and we'll get this one. The inverse function is f raised to minus 1 x in the bracket, and that will be equals to 10 raised to 2x plus 8, and this we are getting our final the inverse function. I hope you got all three solution perfectly. Thank you for listening my video.